Hello! In this video, we're going to look at hydrogen bonding and how it affects some of the properties of water. So a hydrogen bond is an electrostatic interaction between a hydrogen atom, and not just any hydrogen atom, it's a hydrogen atom that's bonded to a highly electronegative atom. So we're looking for a hydrogen atom that's either bonded to oxygen, nitrogen, or fluorine. Okay, so we got that hydrogen atom, and it's interacting with a lone pair on another atom, and that other atom is in another molecule, a neighboring molecule. Okay, so let's look at this picture to kind of understand what this is. Now, one thing we have to distinguish between is hydrogen bonds and covalent bonds. Okay, so hydrogen bonds are intermolecular bonds. So they are bonds, and they're shown here in this red dashed line here. They're bonds between two separate molecules, whereas covalent bonds are intramolecular bonds, and they're shown here in blue. They're bonds within, between two atoms within the same molecule. A good illustration of this that the textbook gives is you can have intercollegiate sports where you've got where you have teams competing between different colleges, so maybe Aquinas College and Calvin College or Alma College, or you can have intramolecular sports where you have teams play within the college. So we've got one team in Aquinas playing another team in Aquinas. So I did intramolecular sports. I did intracollegiate sports in college, but I didn't do any intercollegiate sports. So, great. So hydrogen bonding is really important in water in that it gives it some unique properties. So let's look at those properties. Okay. So they're not as strong as covalent bonds, these hydrogen bonds, but they can affect the physical properties of a substance. So one that's really important is that water has an unusually high boiling point for its molecular weight. If it were behaving like other molecules of its molecular weight, I would not be drinking water. Water would all be steam. And it would be a very interesting planet that we would be living on. Okay. Another interesting property of water is it has a high surface tension. Okay. You can fill a glass of water such that there's a little bit more water in there than what you would expect it to hold, because it kind of creates, it has this surface tension, and we kind of create this little, it bubbles over a little bit before it spills out. Okay, and sometimes you can do cool tricks with water because of that. Okay, and then another really important property is that solid water is less dense than liquid water. So ice floats. Okay, and the reason ice floats is that ice is less dense, or solid water is less dense than liquid water, and density is the mass per unit volume. Often we measure it in grams per milliliter or grams per cubic centimeter. Okay, and the reason solid water or ice water is more dense than liquid water is that it forms this highly ordered complex that has some kind of more space in it. So liquid water is able, these molecules are able to compact more densely. And so in this ordered structure, we have each hydrogen molecule forming hydrogen bonds to four other hydrogen molecules, and we get these kind of hexagonal shapes in there, and it's highly ordered. And that it's just less dense than liquid water. So, and this is kind of a picture of ice floating in liquid water. And it's important to know that this is rare. This is rare among molecules. Okay, usually it's the case that when something's in the solid phase, it's more dense than the liquid phase. And this allows aquatic plants and fish to live in lakes during cold winters because the ice is on top and not on the bottom. All right, so that concludes our discussion of hydrogen bonding and how it's related to some unusual properties of water. Thanks for watching.